So we've talked for a few weeks about acid-base chemistry, about the theory behind it, but that doesn't do us really good unless we can see some change in the world, something that we can measure, something that we want to know about. So this week we're going to be talking about titrations, one of the ways in which that we can measure pH, or measure the concentration of hydronium in solutions. In modern labs, we would mostly do this electrochemically. We can use a probe in solution that will measure the concentration of an ion as a function of the voltage produced inside the probe. We're going to learn more about that in our unit on electrochemistry. But in the meantime, we can still look back at a way that's still used in some applications, and that's a substance in solution that changes color when it reaches a certain pH. That's what we call an indicator. We have indicators that run the complete gamut, really from very low pH up to very high. And these are all water-soluble, weak organic acids that change color as it ionizes. So you may have seen this trick before, but I want to show you just in case, because this is something you actually can do at home to test the pH of all kinds of substances around your own house. So this is a purple cabbage, something that you can definitely buy at your local grocery store, and that color is produced by anthocyanins, which is in fact a weak acid, organic, water-soluble molecule that we can do a really easy extraction and make our own pH indicators at home. And that's really all it takes to make more pH indicator than you'll possibly want. If we want to be more precise, we could check out the concentration by doing a titration curve with a strong base, since we know that it's a weak acid. But for our purposes, just a qualitative color change is really enough to get us going. You can start by mixing solutions of bicarbonate, so baking soda, and just white vinegar. So here we see that starting with the bicarbonate, it turns the blue liquid, the blue neutral water, to a sort of green. And adding vinegar turns our cabbage solution pink. So as an indicator, any substance that we add that turns it either more blue or towards the green end of the spectrum, we know that that's going to be basic. And the stronger the change, the more basic the material. Same thing on the acid side. If it turns it pink or strongly pink, then it's an acid. We can also try adding the acid to the one that's already been exposed to the base to see if we can bring it back towards the acid side. And as we reduce the pH, it does indeed turn more pink. Now you can mix up as many test containers as you'd like and try as many household substances as you'd like. Here, let's try something that I know is quite basic, a cleaning solution, and it turns it green. So you might be a little bit suspicious that the yellow fluid turning a blue fluid green kind of makes sense. Maybe it has nothing to do with pH. So let's try a window cleaner that is itself a blue solution and is also a little bit basic. So when we add it to the other glass, it turns kind of a teal, definitely towards the green end of the spectrum. Now let's try some other liquids now. So coffee and brewed tea. So we'll add in the coffee first. Honestly, not as strong a reaction as I was thinking. Both coffee and tea are at least a little bit acidic. The tea in this case looks pretty neutral, or at least not acidic enough to affect the indicator. If you like a little lemon in your tea, well, that's a different story. Alright, what if we try some of the vinegar from some kimchi? So it also has a yellow-orange tinge, so maybe it would turn it towards the green side. But in fact, it starts to look a little bit pink at first, which it should because it is vinegar after all. But in the end, almost made the solution clear, which tells me that there's some other chemistry going on. Something's reacting with the anthocyanin to make it colorless, which is another consideration you should keep in mind when using chemical indicators. And we'll also try apple juice, not as strongly acidic as lemon juice, and that shows itself in the container too. So there you have it, a homemade pH indicator. Hours of fun for the whole family.